Oh, and I'm wearing my captain hat because we have done with the LPIC, and captain thanks you to following this whole thing. We were on the last part and we were speaking about encryption. Now you know a lot about how SSH happens, but let's talk about a niche part of the SSH which is super cool, and it's called SSH tunnels. It is very fun and very useful and a little bit confusing. You have to practice with it yourself. I'm telling you more than what is needed for LPIC because practically I'm using this every single day in my job. Normally when we do SSH, we SSH to some server or with a user to some server. We provide the password, or now we know how to SSH passwordless, and we connect to the server. We have a shell, we run our commands. This is a general usage of our SSH. Unrelated, but there is one fun thing you can do with the SSH. You can do SSH to a server. It is not common to connect using root, but sorry for doing this. A good person would add this to the hosts. I don't because I'm a bad person. Normally I do this, I connect to that server, permission denied. Oh, because I'm on the other server and that server doesn't have my private keys. Good to know. SSH, I'm on my own computer, root at this. Now I'm connected to that server, I can issue commands. Another less known feature is this. You can add a command to your SSH and it only runs that command and returns back. Very cool. You can check one command or issue one command on a server and you're done. I'm back on my own computer. But this is not SSH tunnel. SSH tunnel, when this is a sample. This is a local tunnel. With this command, I am telling SSH to SSH to this machine and create a tunnel. This is the information about the tunnel. I'm telling it create a local tunnel on this port. Connect it to this. So practically, I'm SSHing to this server as I just did, but telling it open a tunnel. The entrance of tunnel is port 9000 on my own computer because this is a local. And the exit of the tunnel is hackernews.com port 80 because it goes to port 80. It's a web port. So I SSH to this server, this one, created a tunnel from this port on my local machine toward this address. So from now on, whenever I call my computer localhost 9000, this port on my computer, practically this machine will reach to this address and will return back the result to me. Interesting. I will tell you where is the usage. I'm doing this and I say I want hackernews.com port 80 and connect to this machine. So I'm saying SSH to this machine, create a local entrance to the tunnel here. So on my machine, localhost 9000 is connected to this address on this machine. If I run this, I will SSH to that machine. I can create a new window. This is my computer, and I can say curl localhost on my machine connects to port 9000. It's a web server. Practically, when I say go to localhost, so my machine, port 9000, and I have this running, this tunnel will work. This tunnel is connected to this one, and this is going to this address. I agree, a little bit confusing, but just a little bit, not much. This was my command. This is called a local tunneling. Why this is super important and why I'm using it every day. Again, on most jobs, you have a jump box. Or even in my current job, which I'm doing today, and skipping to record this. Not skipping. We are having a demo and I don't have to do anything for an hour or something. What we are doing is we have a server, and that server has a program running on it, which listens to port 5061 on the local host. This is not accessible from the internet. And I need to check this and see if it's working or not. So from my own machine, I will SSH with -L, for example, 8000, or SSH-L, same port, to localhost 5061, to that machine, the address of this machine. For example, user at blah blah. I run this. Now I have created a tunnel. On my local machine, it is called port 5061. So if I go to my local host 5061, I'm entering this tunnel. Where is the exit? On this machine, this is the exit. So when I connect on localhost 5061 on my machine, practically I'm connecting to localhost 5061 on this machine. And I can see this interface. This is why we are always using it practically every day. There are lots of servers like this. Or in another scenario, you have a jump machine, jump box, which is connected to all the customer servers. I need to check the web server on this machine and see if my monitoring is working fine or not. My monitoring is running on 8080 on this machine, which is only accessible in this network and not on the internet. So it's called monitor.8080. What I will do is I will do SSH, local forward, for example, whatever port I want, 1111, port, not fort. Some forts I like. SSH-local 1111 to the monitor 8080 and the address of this machine. For example, user at this IP address which I can connect to. Now if I go to my own browser and say localhost 1111, practically I'm entering this tunnel. This is the local address of the tunnel. And the exit of the tunnel is monitor 8080 on this machine. So practically this machine will call monitor 8080, will show back the answers to me on this tunnel, and I will able to see the interface on this machine. Same thing works for connecting to the remote Git server or whatever. This is super cool and useful. You know a lot about it. Very few people understand good the tunnels. Very, very, very few people, because very few people compared to the whole population understand Linux. Very few of the Linux people understand this tunnel, so you rock. There is also another kind of tunneling, which is called remote tunnels or reverse tunnel, as you may call it. On the previous one, we had this SSH-L local port 9000 connects to this on this machine. So if I go to localhost 9000, practically this machine is calling this address and I'm seeing back the answer. Sometimes you want to do the reverse thing. You can go with SSH-R instead of -L. This port connects to this port on this machine. But this is reverse. So if you go to this machine and call this port, you are connecting to this one on my machine. Why this is useful? For example, you may have a web server on your computer. So localhost 80 is my web server. And this guy wants to see this. I can do a reverse tunnel. I SSH to this machine. Say I have a reverse tunnel on port 8000. So port 8000 will work on this machine, and whoever goes to port 8000 on this machine will connect to this on my machine. This is reverse, just exact reverse side. This is very, very, very fun also. At least in my life, this is less useful, but it's good to know about it. So I can say SSH, reverse SSH, port 8000, so 8000 on that machine, connecting to my localhost port 80 and connect to root at 5161.197.79. Now I'm connected to that machine. This is my machine. On that machine, you can check with fuser who is using this port. Who is using port 8000 TCP? Oh, SSH is listening on this port. My reverse tunnel. I said on reverse machine, open this port and connecting to this on my machine. So if I create a listener here, MC-L port 80, I'm listening on port 80. If someone telnets here on localhost port 8000, practically they are connected to this. So I can say, testing this funny tunnel. This way they are connected to me. Why this can be super useful? I have a machine which is not connected to the internet. And I have a server on the internet. I want to be able to connect to this machine in my home. It's enough to start a reverse tunnel, for example, on port 22. So I would say SSH, do a reverse tunnel on port 2222, connecting to my localhost 22 and SSH to this machine. From now on, whoever is in this machine and connects to port 2222 will be connected to my machine's 22, which is SSH port. So you can do an SSH to localhost to the port 2222 and you will be SSHing into the machine without the incoming internet access. Super cool. Try it. Many of us do have this, so we are able to connect from outside to the machines which don't have the incoming connection. Don't tell your boss. But if you have a server somewhere and the server can reach the internet, but you cannot reach the server, each time you want to work on it, you have to go to that site physically and work with it. You can do a reverse tunnel to a VPS and connect to that VPS, go to the localhost, SSH to the localhost, dash port 2222 as I've described, and you are connected to this SSH. Don't tell your boss and don't do it if it's illegal. Someday something bad will happen and you will be in huge trouble because you did this. Oh, sorry. Quit. So this was the reverse tunnel. Again, very fun. There is also one possibility. Here you saw this. This port is listening only on the localhost. You can do a more general and more dangerous reverse tunnel too. You can say SSH, do a reverse tunnel, listen on whatever IP on this port. So people from outside world can also connect to this machine on this port and they will be connected to this port on your own computer. I'm telling it instead of just the port, I'm saying this IP and this port. And you remember 000 means whatever interface, all interfaces. But if you want to do this, you have to have this configuration set in your etc ssh ssshdconf. Okay, because this is dangerous. Practically, you are able to open ports listening to all interfaces, so people from outside world will be able to scan this using Nmap and see some strange port is open and connect using it to your own computer, which is very dangerous. That's why there is a configuration for this. Another thing which is good to know is dynamic SSHs. Up to now, we are telling everything we needed to the SSH. There is this good shortcut, which is SSH-D to a server. You are saying, I want a port forwarding, but a dynamic one. So if I do this, why this becomes... If I do SSH-D capital 1080 to a server, from now on, my computer will have a port open on 1080, which is a SOCKS proxy. Some people in my country use this to bypass internet censorship. I'm telling my computer to connect to this one and open this port. Whatever with the SOCKS protocol goes to this port is forwarded to this machine and the answer will come back. So if I have a computer which has a very restricted internet connection, I can do SSH-D 1080 or whatever port to this machine which has unrestricted internet. From now on, I can proxy whatever software I want to this port that will go to this machine. It will go to the free internet, will return back, and I will have the answer. Why this is useful in everyday job, even in free world? The reason is you have a machine which doesn't have access to the internet, and you need to install some software here. So it's enough to SSH-D to a machine which has the internet, and then use a software like proxy chains or any method you use to proxy, creating variables or whatever, and configure this to proxy your commands to this address, to SOCKS localhost port 1080, and then you can run apt dnf whatever here and install your software. Practically, you are providing internet to the machine without the internet. This is why this is important. And the last thing in this section is X forwarding, another kind of tunnels which is pre-configured in SSH. You remember, in the Linux world, we said that there is a X11 protocol or X or its implementations which provide the graphical environment to your computer. When you run something graphical, for example, Firefox or X-Eyes, which show some cool eyes, it talks with the X. And X over the networks starts rendering the graphics on your screen using whatever window manager you have or whatever. We have talked about this. But this X works over the internet. So you can have one machine here, even without X, connect from your machine, forward X with dash capital X switch, and whatever graphical you run here will be forwarded to your X session. For sure, you have to have an active and working X implementation. If you are on a Linux, most probably you have it. If you are on a Mac, you can install softwares like X Quartz, which provides X for the Mac. Windows should have it too. So if I connect to the machine with -X and say I connect to 72, this is taking some time because I'm on a Mac, and Mac should bring up the X Quartz, which is the X implementation, and it's a little bit slow to start. Now I'm there and X is being forwarded. If I do for example, X-Eyes command, it runs the X-Eyes graphical program, which is this funny thing which looks at my cursor. Remember, the process is being run on that server. I'm only seeing the graphical part here, which is super cool. Even if a computer does have X, the server does have a X on it. Again, from my computer with X, I SSH using -X. So X is being forwarded for me. And whatever graphical I run here, I will see the outputs. It's very useful if you are connecting to your university and you want to work with your softwares there. You can forward the X and has them here. Or if you want to use graphical mode on a very powerful computer on your server to do your important things. Or if you want to fake that you're at your job or whatever. This is how X forwarding works, and it's super duper cool. Again, if you want it to work, you should have it configured. Let's etc, let me also exit this one. Let's etc sshd config. Here I have a configuration which says X11 forwarding is yes. I should have this to be able to do that. Also, I have pub key authentication here, so I can SSH without password using my keys if it's configured. And I also have gateway ports clients specified. So clients can ask for the server to listen on the reverse proxy things to on all things. That was it. Let's go to the last section of the whole LPIC with Captain.